Hey everybody, Dave Lindbergh in Hong Kong, still with another episode of the THD Podcast. Today, joining us from San Jose, we'll have Ramesh Ramchandani, and he's the CEO of a company called GraphAudio, and they're doing graphene materials for diaphragms, and we'll find out how they're implementing them and all about that stuff. But before we go too far, let's not forget to introduce our sponsor, Alti, the Audio Loudspeaker Technology International. It's a great organization for networking for people building loudspeakers and the whole industry. So we really encourage people to check out their website. We'll put the link up here and direct people to go check out that website. But without delay, as always, we have Simon in Sendai, Japan. How are you doing this morning, Asia time, Simon?
Oh, really good this morning, Dave. Good to meet you, Ramesh.
Great to hear. Ramesh, thank you very much for joining us. We've been planning this for some time, and so we appreciate you taking your time in your evening.
No, thank you very much. Very excited to be here.
Okay, cool. So yeah, Ramesh, graphene has been a buzzword. I've seen a lot of what we call it, incubator or sections of trade shows where there'll be a university, Cambridge University, some really smart guys doing some clever things for all kinds of product applications. But your company is focused on audio. So maybe tell us a bit how you started, or if you want to jump into a presentation to walk us through, let us know how you want to.
No, absolutely. So let me just bring up our presentation here. So so let me jump into the company a little bit. Our company was started back in 2016. We are the only company that is focused on graphene that is really specific for audio. And when I'm saying audio, I'm not just talking human audio range. I'm talking well into the subsonic and ultrasonic ranges as well. So the way the company got started, it's interesting, David, you mentioned that graphene has come from Manchester many years ago, and it's found its way into various applications. But interestingly enough, the way GraphAudio was formed is that there's a professor at UC Berkeley, Professor Alex Settle. He's a professor of physics there. He's also a senior research scientist at Lawrence Berkeley National Labs. He came up with the IP around a graphene transducer for audio applications. So one of our co-founders, actually a couple of our co-founders, saw the value of this IP and actually formed GraphAudio by spinning out the IP license from Lawrence Berkeley National Labs and took a perpetual exclusivity on that license and formed GraphAudio around this. And this was back in 2016. And so since that time, the company has organically developed additional IP. We have perfected the R&D aspect of the graphene for the speaker as well as for the microphone applications. And we're starting to see a lot of traction in the industry today. One of the unique advantages of our graphene is that if you look at the audio applications today, most of the dynamic speaker systems have a, mylar or some PET material. They have a magnet. They have a voice coil to actuate the sound. Our graphene is very simple. It's basically a graphene membrane that is sitting in between two electrodes, and it's energized through an electrical signal that's applied to the graphene. So we basically are looking at graphene as the next generation of audio applications. It's similar to how CRTs came about, and then today, if you look at TVs, they've got LCDs and OLEDs, and you see the transformation of the video technology. Graphene is doing the same thing for the audio technology. And so, in all the advancements that have been made in the display technologies, we are bringing that now to the audio applications. And we're starting to see some pretty interesting dynamics take place with the graphene membrane in that, inherently graphene has zero distortion. It takes very little power, so it's much more power efficient than any other application utilizing a microphone or speaker today, dynamic speaker today. and it's very light mass. So if people looking at reducing weight, people looking at taking less real estate on an application, the graphene is a perfect vehicle for those type of applications. In today's audio input-output technology is completely out of date. It's low energy efficiency. There's poor sound quality, size. People are always talking about shrinking things, and they're running into challenges on how to shrink stuff. And so, graphene has been what our graphene does is basically solve these problems. But the other thing that is really interesting with our technology is that it doesn't have any negative impact on the environment.
Right.
If you look at speaker systems today, they require magnets, and that requires mining for magnets, which is a rare earth material or rare earth mineral.
Yeah.
And with this, you don't have any magnets. So for environmental applications, it's a very, very green technology compared to the incumbents that are out there today.
I would just add to that, if anybody's seen the paper pulping process in making traditional paper cone speakers and the tarring that goes on, it's truly a toxic process. Anything that tar will touch as a byproduct of the cone manufacturing, it destroys everything. So that's a very nice feature that you have there.
Yeah, so our company is very sensitive. I mean, it also, we're looking at the way we grow graphene. I mean, we're trying to make it a very carbon neutral application, and we are very sensitive to that as we are creating our graphene. So as I mentioned earlier, there's a lot of benefits our graphene brings over the incumbent plastic dynamic speakers today. I mean, they're 3 times lighter, they're 10x thinner. One of the most important thing is because it takes very little current to actuate the sound in a graphene membrane, you get, for any portable application, you get a very high extended battery life from it. Usually, if you look at like earbud applications and things like that, 30%, 25 to 30% of the total power is consumed by the speaker. And if we can reduce the amount of current that the speaker has to induce and inject into the transducer, you can automatically improve the battery life from that. The other inherent advantage of this is that graphene has practically zero distortion. So a lot of the and David, I know you heard our demo when we presented it at CES in 2020. Mm-hmm. In that demo, which a lot of people that heard the demo, that was the first thing they noticed was how crisp and clean the sound was, and that is because there is really no distortion that's coming out of this. And that demo we did had no software EQing in it. It was raw sound that you're hearing. And so it's very, very low distortion. The other thing is it's much lower cost, it uses much fewer components over the current plastic dynamic systems that are out there today. And because graphene, it's actually harder than diamond. It's the strongest material in the world. And because of that, it's very durable, it's very reliable. And one of the things that this company, GraphAudio, has done is also, and we have IP around this, is look at how do we start to produce this in a repeatable fashion and through our foundry partners, and offer this to the market. So a lot of significant advantages you would see from graphene.
Okay. Now, I might be mistaken here, but if I remember correctly, electrostat headphones traditionally were pretty heavy on power consumption. And so if you're claiming 30 times battery life plus an electrostatic process, that kind of tells me it must be extremely low power, because I understand the electrostat process I thought was pretty heavy on power consumption.
Yeah, no, you're going to see orders of magnitude in terms of current consumption. There's orders of magnitude less current consumption in the graphene transducer than there is in a plastic transducer.
Okay.
So as a result, the power efficiency is much higher.
Wow. Okay.
So Our GraphAudio being a small company, we started in 2016. The market we are servicing is obviously a very large market. It represents about a $45 billion opportunity. Our focus in the company today has been looking at the headphones and earbuds, but that's not our end game here. We have IP in the company that goes into the ultrasonic. We've come up with the transparent transducer. And so one of the things that we're seeing is that, outside of, earbuds and headphones, there are applications like cell phones, computer laptops. There's AR, VR applications, TVs, home assistant devices. There's even white good applications where people are starting to embed audio sensing systems within things like dishwashers and refrigerators. Look at automotive applications. There's a whole bunch of applications just within the automotive space, from speakers, microphones, to even echolocation system like ultrasonic echolocation, echo detection for park assist or for self-driving applications. And so there's a host of applications here that the company is embarking on. But today, with our headphone and earbud technology that we are creating, this is just the stepping stone to what we plan to do in terms of servicing the market.
Okay.
So one of the things that with GraphAudio, our technology is so unique. We're following the model of the Intel Inside, and that model is where Intel is really the heart of anything. If you look at a computer system today, whether you buy a Dell system or Sony or whatever it may be, the computer on the outside always says Intel Inside, and so we're offering components to all the audio OEMs out there. We want to be able to offer audio to the audio OEMs where they can embed our technology into their headsets and earbuds or whatever application and have that Intel Inside strategy with them. So with that, you get better sound, more efficient, thermal efficient, better power. It's a very cost effective. So from a manufacturing standpoint, we're using less components, and because there's no magnets, there's no voice coils, the process itself from a manufacturing standpoint becomes a much simpler process. And so the net effect of that is you get a cheaper bill of materials and a much faster throughput in the manufacturing process. So very significant advantages, both from a application standpoint in terms of the quality, as well as from the manufacturing of the graphene transducer.
Okay.
So the company today, we're focused on producing transducers for the market, but there's also the opportunity that we can license our technology to OEMs. Today, we are in discussions with several customers. Many of these customers are interested in buying transducers from us, but we also have some customers that are actually looking at licensing our technology as well. So the company is entertaining both the component side of sales, where we do a full transducer system, where we would offer a preamp or an amplifier with the transducer, and then they would essentially buy the full system, embed it themselves, or we can license the technology on both the amp as well as on the transducer.
Okay.
So here I'm sharing with you our evolution of the IP. So we do have a broad IP portfolio today. That first electrostatic graphene microphone speaker IP that you see, that is the original foundational patent that was created at Lawrence Berkeley National Labs. From that, we have the other IP that you see here has all been created within GraphAudio. So today we have been granted the wideband ultrasonic microphone and speaker technology for the transducer. We have 3 that are in the pending mode right now. One is on the high volume manufacturing. The other one is on what we call a tunable acoustic property, which allows us to cut the graphene in different shapes. It's almost like the Japanese art of kirigami, where you cut paper in different fashion. We're doing that with our transducer, with our graphene membrane, and what that does is net effectively it provides different sound fidelity. So if there are applications where customers ask us to tune the capability of the sound, whether it's a low frequency, mid frequency, high frequency, with our kirigami effect, with our kirigami patent, we are able to offer a very focused sound quality in the frequency band of their interest.
Oh, interesting.
The other thing we have is the transparent graphene transducer. So this is going to be very important for a lot of display applications, where we're starting to see where laptops, cell phones, your television, where the actual display itself becomes the speaker and microphone. So what that does, for example, for a television application, today, if you look, the speakers are either coming through the TV, and if you want to enhance that experience, you got to buy a sound bar, you need subwoofers, you need external tweeters, and that essentially is a lot of extra components that you need to buy just to get a full sound experience from the TV. With our transparent transducers, this would be embedded as part of the display, and both you would have the speaker as well as the microphone. But you would not have to buy extra sound bars or subwoofers and all that to get that sound experience, because we could have the graphene, our transparent graphene, tuned to the frequencies again to create that full theater-like experience from a television. Right. And so that is the patent that is pending with us, or we filed disclosures on this, and we are expecting that to be issued here within the next few months. And then, the fabrication of the ultrasonic is something we filed recently here. We expect that to be granted to us in about a year or so.
All right.
So this is our team. My background, I've worked in semiconductors my entire life. I started in design. I was a RFIC design engineer for many years, worked in power management, worked with companies like Zilog, where they were the Silicon Valley icon many, many years ago. I was the executive vice president there. And then after that, I ran a couple of companies, one private, sold it to one of our customers. Another one was a public company that we also ended up selling it to one of our competitors. And so I basically ended up here at GraphAudio. Just before GraphAudio, I was at Google X, working with them on their TPU strategy. I was an advisor to Google, and these guys at GraphAudio came and recruited me to come and run this company and basically take the company from what it had created in terms of its technology and really now bring it to market and monetize and figure out the best way to monetize that technology in the market. So Lonnie Wilson, who's in the center here, he's our co-founder and also our CTO of the company. He's really the brains behind this. We do have a development team that sits in Austin, Texas. Lonnie himself is based here in San Jose. He comes from companies like Fairchild and Intel and AMD. His background is all materials and processing, and he's really the brains behind our graphene technology. And then John Kurzweil, who joined us recently, is our CFO, and as well as our Chief Operating Officer. He, as you can see from his background, he's got tremendous wealth of experience in finance from companies like On Semiconductor, Read Write Corporation. He was the CFO of Cree, CFO of Cirrus Logic, and so we're lucky to have him here. So this is our management team as it is today. So here I wanted to kind of lay out for you the milestones that have been achieved so far. The company was founded in 2016. We secured all the IP in April of 2016. We proved out the tech at CES in 2020. And in 2020, GraphAudio actually won CES's Product of the Day with our graphene technology. And today we have customer validations. We actually, this year in 2021, as we started sampling customers, post CES, as we started sampling them with our transducers, that validation is kicking in today with customers now starting to place purchase orders with us. They've also looked at, some customers are very interested in this technology that they want to also create some exclusivity around this. And so we're starting to see validation of all the efforts that we put into R&D and into our engineering efforts to really now take place from a market standpoint. Okay. So that's pretty much it from our company standpoint. Any questions from you guys?
Yes, certainly. Do these speakers, are they a drop-in replacement for dynamic drivers?
No, they are not. So that's the thing that you need to. There's some re-engineering required because you need a amplifier to operate the graphene transducers. So it takes a different footprint. Now, from a microphone standpoint, our graphene microphones could be easily replacing the footprint of a MEMS mic today.
Okay, and say in the case of speakers, so you need to drive with much higher voltage. Is that
yes?
What voltage range are you talking about?
So today the voltage range is anywhere from say 300 to 500 volts. We are looking to bring that voltage range down. This is on the speaker side, not on the microphone. Requires very little voltage. But on the speaker side, it's anywhere between 300 to 500 today.
And do you need to put a bias? You put a bias voltage on the membrane as well?
Yes. So the electrodes are connected from the transducers. They're connected to the membrane. Yes.
Operates so the electrostatic speaker. You put opposite polarity signals on the two plates either side and bias the graphene membrane.
Correct.
Okay,
that's right.
And, so that bias supply also needs to be fairly high voltage wise.
Yeah, it's 300 to 500 volts. Yes.
Okay. And the signal voltage is also 300 to 500 volts.
That's correct. Yeah.
How do people go about getting an amplifier that swings that kind of voltage?
So we
do you provide that part of the solution too?
Yes. So the one amplifier we had at CES that we demonstrated, it was a discrete design which was developed here at GraphAudio, and that discrete design is being migrated into a chip. So that basically would allow, from a chip standpoint, it would allow us to put in a voltage of say, 3 volts or 5 volts and do a step up to 300 or 500 volts. And so the voltage amplifier that we had at CES did exactly that. It did a step up from the input voltage to really power up the speakers.
Interesting. And on this transparent speaker, how do you get transparent fixed plates either side?
That's the IP.
Yeah, that one. So that one was curious for me. I used to work at NXT out of Cambridge, and we did gateway computers back in the late 2000s with using piezo to make the screen. So there's definitely interest in that category.
Yeah, and so in terms of the frequency response characteristic, you have a fairly limited like a movement X max in the electrostatic and the GraphAudio.
Yeah, so from a frequency response standpoint, if you look at the human audio range, 20 hertz to 20 kilohertz, the response is extremely flat across the entire spectrum, entire frequency spectrum. The interesting thing is, and we have actually operated the SPL levels to like 130, 140 dBs, and we've seen no degradation in sound and all that. So it's very flat. But the more unique, interesting characteristic of this is that if you look at dynamic systems today, or even if you look at other electrostatic systems, as you turn the volume up, the frequency response tends to shift. You know, you tend to see like roll off at the lower frequencies as you increase the volume or as you decrease the volume. The shape of the curve is not linear. But with our graphene technology, that's something we took into our design consideration. If you're running it at, say, 50 dB of SPL, you get a certain response. Let's say you take it up to 100 dB, that exact same response is going to hold across 20 hertz to 20 kilohertz. You will not see any roll-offs. You won't see any shifts. So it's very uniform across the different power levels, different volume levels.
I think I saw just on a previous slide, the smallest you're doing, was that 5 millimeters or?
No, we could go even in terms of speakers, or I mean, our membranes can go even like sub 1 millimeter if you wanted it.
Okay,
It depends. We could scale this from sub 1 millimeter, and the largest I think we've created so far is a 50 millimeter diameter.
50 millimeters.
50, yeah.
Oh, yeah, 50, yeah. And you focused on headphone applications.
So our earbud, the demo that we had at CES, that was a 16 millimeter diameter.
Okay. So actually making it as a disc shape, but it doesn't need right.
It's circular. Yep.
Interesting.
Okay. Now, is this manufactured using a diamond-like carbon process? Is that similar as to how you fabricate the membranes?
No, so we're using a CVD system. I mean, our CVD system is we're growing this in a CVD chamber, and we have a prototype fab that we have in Austin. We're actually it's on the campus of University of Texas in Austin, Texas, in the Merck Center, their microelectronics research center. So we've developed the process there, and it's a production process that we've created in a prototype fab. And we are in discussions with a couple of foundries right now where we want to port the process from there into their foundry. But we're using standard CVD systems to create our graphene.
Okay. Yeah, and I just have a client from Belgium that builds plasma CVD systems. So they were
interesting.
Yeah,
interesting.
Maybe we talk offline about what they're up to.
Yes.
Very, very cool stuff. And is it pure graphene? Because there are some other people out there fishing that, but it's not 100% pure.
This is 100% pure. You can't get any purer.
Yeah.
So there
are people out there that tout, we've got graphene speakers and all that, but they're still plastic membranes, and all they are is graphene flakes that are sprinkled over it. I mean, they're not graphene speakers. I mean, the company GraphAudio owns the IP on a pure graphene speaker or a pure graphene microphone. Nobody else can do this. And if they are doing this, they're violating our IP.
Okay, very interesting.
So yeah, the diaphragm, the membrane is a film of graphene.
It's sorry, Simon?
The membrane is a graphene film.
Yes, the membrane is a graphene film. And so one of the things that we are doing, graphene, as you know, is one atomic layer, right? It's very, very thin. So what we are doing is a multi-layer graphene. So we stack up a speaker system. We're stacking up probably about 200 to 250 layers. So it's about 200 nanometers thick, 160 to 200 nanometers thick, the entire membrane.
Wow.
So it's very, very thin.
Yeah. Do you come up with these sheets of material and then cut it to the shape that you want?
Yes, today we're doing that, but we want to be able to put this into a production process where and that's the discussion we're having with the foundries, where we can cut it out to the need of the application, whether it's 16 millimeters or 22 millimeters or whatnot. And so we'll be able to provide it directly from the foundry that way.
Yeah, and I think like you said about what was it, the tunability, so designing for the tuning and controlling the breakups, you possibly would be able to design it manufacture it in 3 dimensions as well, which could be very interesting for acoustics.
Yes. Yep.
Got me all excited here.
We can't wait to see the market adopt this. It's absolutely going to change the game.
Cool.
And so we're excited about it, but what's even more exciting is to see our customers be excited about it, and they're starting to see the potential. And so I think we're going to create a whole new. I always say we're creating a whole new plateau on acoustics, because if you look at the audio realm, audio industry today, it has plateaued out in terms of what improvements it could bring to the fidelity and all that. And so with our graphene technology, we're taking that plateau and taking up to a newer level, much higher level, to be able to now bring other type of benefits and other experiences to audio that has not been be able to accomplish before.
All right. Simon, do you have any more questions?
No, that's it.
All right. Well, yeah, Ramesh, thanks so much for joining us today. Anything else you'd like to add for the people watching?
No, I just, we're working on a headphone demo. So one of the demos we had at CES in 2020 was an earbud. We are putting together a headphone demo, which is going to have spatial audio effects and all that embedded in it through our graphene. So I think I'm very excited to be able to share that with the market. And we're hoping to have that in 2022. That we could demo for, that'll be our next demo that we bring to the market. And so we're excited about where we're headed, and hoping to see, every home, every car, every audio application have our graphene embedded in it in the next 3 to 4 years. So we're quite excited about that.
Okay, great. So, all right, everybody watching, don't forget to like, subscribe, share. We'll put some contact details for the website for GraphAudio in the description below. And so thanks, Simon and Ramesh, for joining us today. We appreciate that.
Thank you.
Okay. See you, everybody.